Let's take a look at this identity. We're supposed to prove that the left side is equal to the right side, but let's take a look from which side we're supposed to start solving this problem. I'm going to start this time from right side. Let me copy down the right side. I have cosine 3 alpha. I can rewrite this cosine as the cosine of the sum of two angles. Cosine alpha plus 2 alpha. Because I have the cosine of the two angles, I'm going to use the formula for the cosine of two angles and rewrite this expression as cosine alpha times cosine 2 alpha minus sine alpha times sine 2 alpha. Now, let's take a look what we're supposed to do next. I have cosine of the double angle and I have sine of the double angle. I'm going to use the formulas for sine and cosine of the double angle in order to simplify this expression. So I'm going to write cosine alpha, and instead of cosine 2 alpha, I'm going to write cosine square alpha minus sine square alpha. Cosine square alpha minus sine square alpha minus, and I have sine alpha. I have sine of the double angle. Instead of sine 2 alpha, I'm going to write 2 sine alpha cosine alpha. Next, I'm supposed to perform the multiplication. So that's why I'm going to have cosine cube alpha minus cosine alpha sine square alpha, and I have minus, because I have negative, sine alpha times 2 sine alpha cosine alpha is equal minus 2 sine square alpha times cosine alpha. Next, you're supposed to look at the original equation, original identity. Please notice that we are working right now on the right side. On the left side, we do not have any signs. Means we have to eliminate the signs which we have somewhere over here, because we have to end up with cosines only. We have sine square and I have sine square. That's why I'm going to use right now the Pythagorean relation, which says that sine square theta plus cosine square theta is equal 1. We said we want to eliminate signs. That's why I have to solve this identity for sine. That's why I have to move my cosine to the right side, and I'm going to end up sine square theta is equal 1 minus cosine square theta. So anytime I'm going to see sine, I'm supposed to write 1 minus cosine. I have cosine cube alpha minus cosine alpha, and instead of sine square alpha, I'm going to write 1 minus cosine square alpha minus 2 times 1 minus cosine square alpha times cosine alpha. Let's continue. We have cosine cube alpha minus cosine alpha times 1 is just cosine alpha. Cosine alpha times cosine square alpha is equal cosine cube alpha, and we have negative times negative gives me positive, so this is positive cosine cube alpha. And I have negative 2 times 1 is equal negative 2, and don't forget about this cosine. Cosine alpha times negative 2 gives me negative 2 cosine alpha. Now negative 2 times negative cosine square alpha is equal positive 2 cosine square alpha times cosine alpha is equal positive 2 cosine cube alpha. Next, we're supposed to combine the like terms. We have cosine cube alpha, and we have 2 cosine cube alpha. So this is 4 cosine cube alpha. And we have negative cosine alpha, and negative 2 cosine alpha is equal negative 3 cosine alpha. Now, please compare this expression to the left side of my identity. As you can see, both of them are identical. That's why we prove that left side is equal to the right side of my identity.